Okay, good evening. This is Professor David J. De Los Reyes. It's February 2, 2023. The time is almost 7 o'clock in the evening here in Los Angeles. Okay, my topic for tonight will be a long-form video on algebra. I would like to discuss a very important concepts that is being used in algebra and how to compute for the value of x. If we are given any quadratic equation and it is not solvable by using the so-called factoring by inspection, there is a formula on how to compute for the value of x, and that formula is actually the so-called quadratic formula. So for tonight, I will be giving a long-form discussion, long-form video discussion on the derivation of the so-called quadratic formula. Okay, let's proceed. I will check my camera first. Oh, it's fine. I will try to bring out a discussion that it seems we are a given problem. So actually, when I give a long-form video discussion, it's in the form of a so-called problem. But that problem involves concepts. And for tonight, I will be deriving a very practical concept, a very useful concept in algebra. Okay, I will try to bring out the problem. The problem is, derive the quadratic formula. We are to derive this equation here. X equal to negative b plus or minus the square root of b square minus 4ac all over 2a. If you study mathematics or you have graduated from engineering course, you will not forget this formula. And in engineering, we call this the so-called quadratic formula. It is the formula on how to compute for the value of a quadratic equation if that equation is not solvable by using the so-called factoring by inspection. Okay, let's proceed with the solution. The given general form of the quadratic equation is actually ex squared plus bx plus c equal to 0. This is the quadratic equation. Why quadratic? The highest power of x is actually 2, and quadratic refers to the power 2. The first quotient, the first coefficient is a, the second coefficient is b, and the pure constant term is actually c. All the operations are plus. Okay, so these are all plus. So if there come a time that there is a negative sign over there, you assume for the meantime that the operation is still a plus, okay? Because a plus multiplied by a minus will become a minus. So there could be a time that this will be negative, okay? But our general form is actually plus, so you adjust properly, okay? This is a plus. Okay, to derive the quadratic formula now, this is now pure algebra, guys. Divide all terms by a. So ex squared divided by a will be ax squared. Bx over a will be b over a times x. C over a will be still be c over a. And the right hand side is 0, right? So 0 divided by a. I just presented the right hand side to be divided by 0 because we divide all terms by 0, by a rather, in which the value 0 over a is 0. So this is actually 0. Because you might ask, you divide the left hand side by a, and how come you did not divide the right hand side by a? I divided it, so a 0 over a will still be 0, and this is now 0. Okay, that's one step. What will be next? To make the left-hand side a perfect binomial, a perfect trinomial square, okay, we will transpose this one first to the right. So what will I do? Okay, if I will transpose this to the right, this should now be equal to negative c over a, right? And to compute, to make this one a perfect trinomial square, okay, we will compute for the value of the pure constant term, which must be added on the left for it to become a perfect trinomial square. And the proper way and how to take that one is actually, it is given by this equation here. Take 1/2 of the coefficient of x. The coefficient of x is actually b over a. Take 1/2 of the coefficient of x. Then try to square that one. If you try to take the square of this, then put it on the left hand side. What will come out on the left hand side will be a perfect trinomial square. So 1/2 of b over a quantity square will become 1 times b is b. B to the second power will be b square. 2a quantity square will be 4a square. So the needed constant, it will be constant because b is a constant, is a constant. A constant all over a constant will still be constant. So the needed constant on the left for it to become a perfect trinomial square will be the value of b square over 4a square. So, okay, continuing with the solution, x squared plus b over a times x, okay, plus b squared over 4a squared, okay, and this should be equal to negative c over a plus b squared over 4a squared. I added this one on the left and I added this one on the right, so there's no violation, right? We could do it, okay? After adding b squared over 4a squared on the left, what the factorable form will be the quantity x plus b over 2a quantity squared. Okay? And the right hand side, this is now pure algebra. You're adding two terms. The first term is not different from the second term, so you must have to use your knowledge on the so-called combining two fractions with different denominators. Okay, so what will come out will be, you multiply this one. You've been seeing this in the shorts video. You try to cross multiply this one. So this will become 4a squared c. Okay, then you multiply this one. You've been seeing that on the shorts video, right? A times b squared will be ab squared. All over the common denominator, the product of the individual denominator. So this will become 4a, this is square, this is a to the first power, so the resulting denominator for the right hand side will be a 4a cubed. For the left hand side, if you try to expand this quantity here, what comes out is actually this. Okay? We try to square. The square of x will be x squared. The middle term will be b over a times x, okay? b over 2a times 2. So actually this 2 here cancel with this. So what will come out will just be simply b over a times x. And the square of b over 2a is actually b squared over 4a squared. So actually the factored form of the left hand side is actually, as I have told you a while ago, if we add b squared plus 4a squared on the left hand side, what will come out? It will be a factorable and it will become a perfect trinomial square. That is x plus b over 2a quantity squared equal to. For the right hand side, we combine it already by using our knowledge of the so-called addition of fractions with different denominators. Okay? You cross multiply this one plus this one. The resulting common denominator will be the product of this. You're seeing this on the shorts videos. Okay? So what will come out? Continuing with the solution, this will be x plus b over 2a quantity square equal to. There is a common factor a on the numerator. We bring it out. Okay, then we try to rearrange. We'll write first the positive thing, so it will be b squared, okay, minus 4ac. Because the product for ac times a is actually the first one. And the product ab squared is actually the second one. So I just rearrange it by I bring out a. There's common factor a all over. Okay, the denominator is actually 4a cubed. But it can be written as 4 times a times a squared. So actually this a here, cancel with this. Okay? So x plus b over 2a quantity squared, this should now be equal to, since this is gone, it seems this is 1. Because 1 times this is just b squared minus 4ac. And for the resulting right hand side, it will now be b squared minus 4ac. This is gone, right? It seems this is 1. So this is 4a squared. Okay? So to compute for the value of x, we must have to eliminate this to here. And to eliminate this to here, we raise all the terms to the 1/2. Okay? So what will come out on the left? X plus b over 2a quantity squared. Raise that again to the 1/2. So actually, we will now apply the so-called laws of exponents over here. 2 times 1/2 is actually 1 because these two here cancel with this. So what remains on the left will just be simply x plus b over 2a after taking the square root. And for the right hand side, we do not know the value of b squared minus 4ac over 4a squared. So for the meantime, we will take all these values, we'll raise that to the 1/2. Right? So x plus b over 2a, this should now be equal to, for the right hand side, this is numerator, denominator. So if we take the square root, we will take the square root of the numerator. For the meantime, we do not know the value, so we just express it as simply b squared minus 4ac, the square root. And for the bottom portion, it is 4a squared, right? So it can be written as 2 squared times e squared, all raised to the 1/2. So again, we simplify this one by using, what do you call this? Laws of exponent. 2 squared raised to the 1/2, these two here cancel with this. A squared raised to the 1/2, these two here cancel with this. So what comes out for this is just simply 2a. So x plus b over 2a, the square root of the right hand side, it will be the square root of the numerator over the square root of the denominator. But since we do not know the value of this, we will place the sign plus or minus over here. The square root of b squared minus 4ac. I want to emphasize on this one. The radical sign, without any number here, it is understood to be square root, right? Okay? I've been seeing short videos that if there is a 3 here, they still consider this one to be square root. That's wrong. Okay? So I want to emphasize on this one. If the number here is missing, it is understood to be square root. But if this is 6, it is not square root. It is the 6th root. Okay? I want to emphasize on this one. So x plus b over 2a, this should be plus or minus the square root of b squared minus 2a. And the square root of 4a squared is actually 2a. They are perfect square. 2 is a perfect square, a is a perfect square, so the square root will just be simply 2a. Because if we try to square this one, what comes out is 4a squared. So the square root of 4a squared is just 2a. Okay? Then solving for x, we transpose this on the right. It will be negative b over 2a plus or minus the square root of b squared minus 2a minus 4ac all over 2a. And if you try to notice it, the right hand side is actually 2 terms. They are under the so-called They are both fractions, but luckily the denominator are the same. So actually we could now combine this one, no problem now. So x now, this is all over 2a, right? This is 2a, this is 2a, so the simplification will just be the sum of the numerator, okay, all over the common denominator 2a. They are both the same denominator. Okay, so this should be negative b plus or minus the square root of b squared minus 4ac. And this is actually the quadratic formula. It is this. So guys, this is actually the so-called derivation of the quadratic formula. So if you are now an engineer or a mathematician or a professor teaching mathematics, okay, even though you're dreaming, you don't forget this formula. And we call this the so-called quadratic formula. That is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? Okay, I will try to give an example illustration, just an illustration for the so-called application of the quadratic formula. This is 0. Supposing we are given the quadratic equation x squared plus 5x plus 7 is equal to 0, and the problem is asking for the possible values of x. Okay, the first solution of this should be by factoring. The possible factors of x will be x and x, right? And the possible factors of 7, unluckily 7 is just what you call this, an odd number. So no matter how you multiply this one, the resulting number 7 will just be a combination of 7 and 1, right? Okay, this is quantity, this is quantity. Since this is 7, it's a must that this should be plus, or this should be plus for it to be 7, right? Or it's possible also for it to be plus 7, negative 7, and minus 1. Because the product of negative 7 times negative 1 is plus 7. But since the middle term is plus, okay, obviously the sign of 7 and 1 are both plus. Okay? But if you try to compute for the middle term will be the product of this, 7x, plus the product of this. X times 1 will be x, plus x. And what comes out is actually 8x. And this 8x here is not equal to the given middle term. Since the resulting 8x is not equal to the middle term, we could not use factoring. So it's a must that we should compute for the value of this using the quadratic formula. Okay? You just place the value of a equal to, b equal to, and c equal to. The coefficient of x squared is 1. The coefficient of b is x is actually 5. And the coefficient of, or the pure constant is actually 7. So we now know the value of a, b, c. You just substitute here, okay? Then you could compute for the possible values of x. As simple as that one. So you should know, guys, when to use the quadratic formula. If factoring by inspection, the rows will not come out, you should use the quadratic formula. Okay, that's it. That's the quadratic formula. That's the solution. And if we try to continue this one, what will be x now? X will be equal to negative b, this is negative 5. Plus or minus. Okay, we'll go automatic. 1 square is 25, right? 25. B square. Minus 4 times the value of a, which is 1, times the value of c. What is c? It is 7. Okay. So what will come out for the value of b squared minus 4ac? It should be 25 minus 4 times 1 times 1 is 28. So actually what will come out inside the radical will be negative 3 all over 2a. 2 times 1 is 2. X now will be equal to negative 5 plus or minus. Since there is a negative sign inside, we could put this one as simply g square because g square is actually equal to negative 1 times 3 all over 2. So actually what comes out will be a complex number. X now will be equal to minus 5 plus or minus the square root of g square is j. And the square root of 3 is just the square root of 3 all over 2. So there are two possible solutions for x here. I will place it here. Oh, sorry for that. X1 now will be, it's a complex number. The first root will be negative 5 using the plus sign plus j3 square root of 3 over 2. Okay? And x2 by using the negative sign will be negative 5 minus j the square root of 3 all over 2. So actually this is the solution of the given quadratic equation x squared plus 5x plus 7, and they should be equal to 0. Unluckily, it's a complex number. So that may be the reason why we could not factor it by inspection. Because if you try to factor it by inspection, the middle term will be wrong. What comes out will be 8x. And this 8x is not equivalent to 5x. Since they are not equal, okay, it's a must that we use the quadratic formula. That's the importance of the so-called quadratic formula in algebra. Okay guys, that's it. I will be developing my algebra topic on my channel. So I will be consolidating all the topics under algebra for it to be under algebra discussion. Okay, if you like my topic for tonight, please click like. And if you want to subscribe to it, my YouTube channel is at youtube.com/@Prof. Okay? And if you want to share it, please click share. Good evening, Los Angeles.